All right, welcome back. So we got another problem. This one's a long day for me too. Um, but okay, we're gonna have another sort of situation coming up here with this problem. So this is number 24, and it gives us y double prime minus y equals g of t. Okay, y of 0 equals 1, y prime of 0 equals 2, where g of t equals 1 if t is less than 3, and t if t is greater than 3. We don't worry about what's going on at 3. So basically, if things have a problem one place, it's fine, as long as it's not a asymptote. You have asymptotes, then you have to worry about things. But here, it's just a jump discontinuity at 3. We're just going to sort of ignore it, which is what you do, okay? But we still have to take the Laplace transforms of this stuff. So let's get started. So I'll do that in blue. L of y, let's call that script y. L of y prime, let's call that s. Let's move that around a little bit. S script y minus s y of 0 minus y prime of 0 equals, of course, actually it's y double prime. Boo, boo. Okay, equals, and that should be s squared. S squared y minus s minus 2. Okay, we also need to do the Laplace transform of this g of t. Now remember what the Laplace transform of g of t is. Now there's an s on there, right? It's the integral from 0 to infinity e to the negative st g of t dt. Now that's going to be two separate integrals. That's the integral from 0 to 3 e to the negative st dt plus the integral from 3 to infinity of t e to the negative st dt. Okay, we're going to need s to be greater than 0. Okay, I'm not going to bother with doing that. So that actually, hold on. So that becomes, I actually did this one in my, yes, I did this one on the computer, but easy to see. So this one is 1 over s, 1 minus e to the negative 3s, plus e to the negative 3s over s squared, plus 3 over s, e to the negative 3s. Okay, so the Laplace transform of our g of t is this. I'm not going to bore you with the details. I just did it on the, actually I did it on the, using Sage. Okay. So our total differential equation becomes, make it a little smaller. Okay. So it becomes s squared y minus s minus 2 minus s y equals 1 over s, 1 minus e to the negative 3s, plus e to the negative 3s over s squared, plus 3 over s e to the negative 3s. Okay? Yes, that's what I got yesterday. Okay, let's go ahead and start solving. So we're going to start isolating y, getting it, and then we're going to do the inverse Fourier transform. So we're going to isolate y first. S squared. Oh, there should be no s here. Let me keep that in there in red because it's bad. And so you can see why I know that it's not supposed to be there. So when I do that, I keep that there, and then on the other side, I get this mess. Plus 2 plus s. So how did I know that s minus wasn't supposed to be there? I looked back at my original equation, and I was like, wait, there's no s there. What the hell? That should be a 1. Okay, so now we've got something. Okay, now I'm going to go ahead and split the right-hand side into 2 different parts. There's going to be the parts that include the e to the negative 3s and the parts that don't. All right, so I'm going to have y times s squared minus 1 equals. Now, so I'm going to have 1 over s plus 2 plus s, okay, plus, now I'm going to have an e to the negative 3s, 1 over s squared, minus 1 over s, plus 3 over s. Okay. So far, so good, right? All right, let's combine these things first. Okay, so we're going to combine them to have one big old fraction. Not one, actually, 2 big old fractions, one with an e to the negative 3s, one without. So y times s squared minus 1 equals, what's this? 1 plus 2s plus s squared over s. Okay, plus e to the negative 3s. Oh, let's move that a little bit just to get it out of the way of my new stuff. There we go. Okay. I swear Apple should be paying me promotions because I love this thing so much. I'm sure you guys can see it. So now we're going to have this thing over s squared. It's going to be 1 minus. Now, these are going to combine to be positive 2. So actually plus 2s over s squared. So far, so good? Any questions? Too bad because you're not here. Ask them at the live session. Okay? So y equals, write this as s squared. I was tempted to write it as s plus 1 squared, but no, not in the numerator. S over, I'm going to write s squared minus 1 as s plus 1, s minus 1. Okay, plus e to the negative 3s that down just a little bit, e to the negative 3s. Here we're going to have 1 plus 2s over s squared, s plus 1, s minus 1. Okay, so there's our y. Okay, now let's go ahead and do the partial fraction. We actually have two different partial fraction decompositions to do. Okay. Let me move things. Actually make things a little smaller too. All right. Okay, so we're going to do a partial fraction decomposition on this. And a partial fraction decomposition on this. But I'm going to get rid of the e to the 3s. So we're going to do partial fractions now. Okay, and it's actually, they're not hard partial fractions even. Okay, so this is going to be some a over s plus b over s plus 1 plus c over s minus 1. I'm just checking to make sure that we didn't have the extra. Okay, this one is going to be a little bit trickier. That's going to be, let's do d over s plus e over s squared plus f over s plus 1 plus g over s minus 1. Okay, do each one separately. So we're going to have s squared plus 2s plus 1 equals a times s plus 1 s minus 1 plus b s minus 1 plus c s plus 1. Okay, and then the other one's going to be 1 plus 2s or 2s plus 1 equals d times s plus 1 s minus 1 plus e s plus 1 s minus 1 plus f s squared s minus 1 plus g, am I running out of space? No. G s squared s plus 1. Okay. Let's make a little bit of room here. To actually make a lot more room. Okay, so now let's look here. What happens when s, say, equals 1? Okay, we can even do both sides at the same time, or both pieces at the same time. When s equals 1, this goes away, right? So on the left-hand side, we're going to get what? 1 plus 2 is 3, plus 1 is 4. On the right-hand side, we get 0, 0, c times 2c. So c equals 2. Okay, let's take a look at the other one. When s equals 1 here, we're going to get, on the left-hand side, we're going to get 3 equals, now, 0, 0, 0. We're left with just g. Okay, so we're going to be having what? 2g. So g equals 3/2. Okay, let's try another. Let's say s equals 0. That's going to get rid of some stuff. When s equals 0, 0, 0. So we're going to have 1 on the left-hand side here. And we're going to have what? 1 times -1, so it's going to be negative a. So a equals -1. I'm just making sure it's all coming out like I did yesterday. Okay. Right-hand side, s equals 0. I'm sorry, the other one. Here we're going to have, that's going to give us 1. On this side, on this right-hand side, 0, 0, 0. So we're going to have -2e. Okay, so e is -1/2. Okay. All right. Let's see. What else do we need? S equals -1. Okay, s equals -1. So when s equals -1, starting to run out of space on my thing here. So when s equals -1, this is going to be what? 1 minus 2, -1, 0. Ooh, ooh. 0. And on the right-hand side, we're going to have, well, this is automatically 0. This is automatically 0. So we're going to have, wait, yep, this is automatically 0. So we're going to have what? B times -b, -2b. Well, it's still going to be 0. So -2b. So b equals 0. Let me highlight that so it's easy to see later. Okay. Here on this side, we're going to have -2 plus 1 is -1. And what's going to be left over? So when s is -1, 0, 0, 0. So we're going to have 1, -2f. So f equals 1/2. Okay, we're still missing 1. What are we still missing? We've got E, we've got F, G, we need D. Okay, so D. How we're going to find D is we're going to match, let me Google it, or let me zoom in there. We're going to match the power of, or we're going to match the S term. Okay, so I just want you to see that's what's going on. So let's take a look at each one. So S term, it took me a while to see it. It's not like I just knew, I just had to see. Okay, but I had to see that this was going to have no S term. This was going to have no S term. And actually, more interestingly, this was going to have no S term either, right? Because this is going to be S squared minus 1. So this is the only one that's going to have an S term. And here we have a 2. So matching S, we're going to get 2 equals, so when I do that, it's going to be S times S squared minus 1. So it's going to be -D. So D is going to be -2. Okay, that was the partial fraction decomposition. All right, just making sure that I have what I had yesterday. Let me just double check that, because yesterday I had d equaling -1. And that's because I was wrong yesterday, so I'm right today. Okay, so let's just really quick write up our y, and then we'll go on to a new page for the rest of it. Okay. Okay. So y equals. Now y, remember, has two pieces. This piece without the e to the -3s, this piece with the -3e to the 3s. Okay. So y equals -1 over s, no s plus 1, plus 2 over s minus 1, plus e to the -3s, -2 over s, minus 1/2 times 1 over s squared, plus 1/2 1 over s plus 1, plus 3/2 1 over s minus 1. Okay, so this is our y. Okay, so just going forward, like I'm just picking it off, right? A over s, a was -1. B was 0, so that term went away. C was 2, so I went and put that 2 over s minus 1. Okay, then we had the e to the -3s on this stuff. D was -2. E was -1/2. So -1/2 times 1 over s squared. F was 1/2. So the 1/2 goes with the 1 over s plus 1. And then G was 3/2. Okay, so the 3/2 goes with the 1 over s minus 1. We go a new page. Sorry, I'd like to, but it would make it way too small. Let's copy this over. Okay, so now we've got to find y. Okay, so now, first thing, inverse Laplace transform of 1 over s, we already know that's going to be 1. So that's -1. Plus 2 over s minus 1, that's 2 e to the -t. We just got to look at the, sorry, e to the t. Right? You just got to remember Laplace transform of e to the at is 1 over s minus a. That's just what we got to remember. Okay. Now, when you look at something, there's one of the Laplace transforms you have is that f of t minus a. This is number 10 in the list. Times u of t minus a. Okay. The Laplace transform of it is e to the -as f of s. Okay, so this is the one we're actually using. So what's this mean? The u of t minus a is actually, this is a step function. Okay, so this is 1 if t is bigger than or equal to a, and 0 if t is less than a. All right, wherever you have the greater than or equal to, the equal to sign, it doesn't really matter. It's basically considered the same function. Okay, so I could for this one do that. Okay, you'll see, you understand why, because our original step wasn't defined at 3. So I could do the same thing. It doesn't make a difference in the solution. Okay? Okay, so the way I'm sort of thinking about this is I should remember this is going to have a step at 3. Okay, just based on our original problem. Okay, so our step, this is going to be then, let me put that in between here. So those were easy, but now we're going to have this u of t minus 3 going on. Okay, that's all that's really going to happen. Okay, we're also going to have to take the f is going to be t minus 3 as well. So we're going to multiply. Okay, and that's going to be, so -2. Now, we know the inverse Laplace transform of s is 1. Good. Okay, minus 1/2. Now, the inverse Laplace transform of s squared is t, but we're going to have this minus a. All right. Okay, plus 1/2. This is going to be e to the negative, instead of t minus 3. Okay, plus, let me move this over a little bit. Three halves. This is going to be e to the, instead of t minus 3. Okay, and sort of the way to understand what's going on is, remember, everything's just sort of getting shifted by that, the fact that this has a jump, or just a jump at t equals 3. Okay, so that's where everything should be happening. That's where the action should happen. Okay. All right. Anything else? Just check. Let me just, this, of course, let me change that to just -2. Okay, which in mine I think was -1. It was -1 because I made a mistake. But that's it. So that's this problem. One more problem to go. I'll see you in the next video.